Hello, class. This is concentration and solubility part 2, the second part of the previous video. Um, so right now I have the salt at the bottom of my Erlenmeyer flask. I don't know if you guys can see. Yeah, I have the salt. It's dry after having it in the sun. Okay. So the next step with the follow-up is weigh the Erlenmeyer flask with the salt inside. So here is my scale. Turn it on. Okay. Scale is at 0. All right. And I'm going to measure it. I'm reading 77.80 grams. 77.80 grams. That's salt and salt with Erlenmeyer flask. $77.80 grams. And step 12, actually 11, step 11, determine the mass percent of salt dissolved in the saturated salt solution. In order for me to determine the mass percent of the salt dissolved, I need to find the mass of the salt by itself. Because the mass percent of the salt is mass of the solute divided by the mass of the solution times 100. I don't have the mass of the solute yet, which is what I'm going to calculate first. In order for me to find the mass of the solute, earlier in the previous video, in part 1, I had weighed the Erlenmeyer flask by itself, empty. It was 74.77 grams. That was the weight of the Erlenmeyer flask empty. So the mass of the solute, the salt, is the mass of the salt with the flask minus the mass the mass of the salt. Is the mass of the salt with the flask minus the mass of the Erlenmeyer flask empty. Migraine. Okay, so mass of the solute is 77.80 grams minus 74.77 grams, which gives me 77.80 minus 74.77, 3.03 grams. That is the 3.03 grams. That is the mass of the solute. Now, the mass of the solution, since we use 10 milliliter of deionized water, 10 milliliter is also equal to 10 grams. So the mass of the solute, the mass of the solution will be the mass of the solute plus the mass of the solution, of the deionized water, which is 10 grams. So that'll be mass of the solution will be 10 grams plus the 3.03 grams, which is 13.03 grams. That is the mass of the solution. Now I can calculate the mass percent of the mass percent of salt. So mass percent of salt will be the mass of the solute, which is 3.03 grams, divided by the mass of the solution, which is 13.03 grams, times 100. So 3.03 divided by 13.03 times 100, 23.25%. 23.25%. Mass percent is 23.25% of salt. Okay, now step 12. Determine the mole salt dissolved in the saturated salt solution. In order to calculate the mole of salt dissolved in the saturated solution, we have to first find the molar mass of salt, which it's not. Yeah, we need to find the molar mass of salt. The molar mass of salt is 58.44 grams. Is the molecular mass, I meant to say, the molecular mass of salt. It's the molecular mass of sodium plus the molecular mass of chlorine, which is 22.99 grams plus 35.45 grams, which is 58.44 grams. Molecular mass of NaCl is 58.44 grams. Now, in order to calculate the mole of salt dissolved in a saturated solution, it's to calculate the mole of the 3.03 grams of salt, because that was the amount that was dissolved in the solution, the 3.03 grams of salt. So the mole of salt is the mole of the 3.03 grams, which is 3.03 grams multiplied by 1 mole of salt of NaCl, which is the divided by 58.44 grams. So it's 3.03 divided by 58.44. 3.03 divided by 58.44. 0.518. 0.0518. 0.0518. 0.0518 mole. All right. Now we have step 13. Calculate the molarity of the salt solution. To calculate the molarity of the salt solution is the mole of the solute divided by the liter of solution. Is the mole of the solute divided by molarity. We already know the mole of the solute, which is 0.0518 molarity. And then the liter of solution is the 10 milliliter, which we will convert in liter. We know that 1 milliliter is 1,000 liter. 1,000 milliliter is 1 liter, I meant to say. Yeah. Can I make the calculation? So 10 milliliter is 0.001 liter. Yep. 10 milliliter is 0.01 liter. So the molarity of the solution, the molarity of the salt solution is the mass of is the mole of solute, which is 0.0518 divided by 0.01 milliliter. I mean 0.01 liter. Zero point 0.0518 divided by 0.01 5.18. That's the molarity of the salt solution. Okay. Now, for the second for the second step of this lab, which is the starch solution, I had put the dialysis tubing of the 1% starch solution. I mean, the dialysis had 1% starch solution, and I had placed it in a 3% starch solution. And after 3 days, we're going to weigh the dialysis to see how much it weighs now. From the last time, it was 16.74. 16.74. I'm going to weigh it now to see how much it is. Okay. I'm reading 16.17 or 8. 16.18. 16.18. All right. This is the end of the second part of the concentration and solubility lab project. Thank you very much.